Johannes Kepler was born at 1:07 p.m. on December 27, 1571, in Wilderstadt, Württemberg. For the most part, he was a sick child who grew up poor with his two parents who did not do too much for a living. As Kepler got older, his intelligence was beyond what many expected from him, and he was fortunate enough to be given a scholarship to study at the University of Tübingen in the study of the Lutheran ministry. He was fascinated by the ideas of Copernicus and eventually became a mathematics teacher in Graz. While he was a teacher in Graz, he wrote the first outspoken thoughts of many which expanded the minds of scientists and questioned if their current theories even made sense. In the late 16th century, scientists believed that the planets in our solar system revolved around the Earth in perfect circles. Kepler eventually left his job to study with Tycho Brahe. Tycho Brahe was a famous astronomer who made some of the most accurate celestial observations of his time and challenged the belief in how the universe was organized. As Tycho and Kepler joined forces to look into their small theory, they deeply questioned what exactly was revolving around what. Kepler mainly led in the theories as Tycho followed. Kepler came to the idea that the planets in our solar system revolved around the sun. With Kepler's math and long studying of stars, he realized we don't even travel in perfect circles. He realized that we travel in long, stretched-out circles we know today as ellipses. Kepler gave us the basic idea that we are not in the center of the universe, and he also gave us the idea of how our planets revolve. He came to the three basic planetary motion laws that we use in a lot of our science today. The first law was called the law of ellipses, which basically said the path of the planets about the sun is elliptical in shape, with the center of the sun being located at the sun. The second law, the law of equal areas, explained that there is an imaginary line drawn from the center of the sun to the center of the planet, which sweeps out equal areas in equal intervals of time.
Fascinating.
His third law, the law of harmonies, explains ratio of the squares of the periods of any two planets is equal to the ratio of the cubes of their average distance from the sun. Johannes Kepler is remembered for discovering the three laws of planetary motion, but he also did important work in optics and gave the first mathematical treatment of closing packing of equal spheres and gave the first proof of logarithms working. Because of Kepler's discoveries, he has benefited the world of science, specifically astronomy and mathematics.
Today we're going to look at Kepler's first law of planetary motion using a few objects that you can find around the house. I've grabbed a marker, a couple screws, and a large surface area to work on, in this case a manila folder. I've also grabbed a piece of string and my little brother's anthropology notebook. Don't tell him that though. Let's assume that we're going to look at the Earth moving around the sun. Let's also assume that the sun is the only foci that we know of. This screw is going to represent that foci. The string is going to represent the gravitational pull of the sun, and with the marker we'll be able to trace out the path that the Earth would follow if there was only one foci. As you can see, the shape is nearly perfectly spherical. However, Kepler's first law tells us that there exists two foci for every orbit. In this case, we'll still keep this screw as a sun, and over here we'll put in the new foci, which scientists are still trying to determine. We know it's there though. The string is still going to represent the gravitational pull of the sun, and with the marker we'll trace out the new path of Earth's orbit. As you can see now, after removing this other foci, the orbit of the Earth goes from being spherical to elliptical. There's a point where the Earth passes closer to the sun, known as perihelion, and a point where the Earth passes farther from the sun, known as aphelion. Kepler's first law tells us that all objects in orbit around one another have this elliptical shape.
Please, Spock, do me a favor. And don't say it's fascinating. No. But it is interesting.